Good morning, good afternoon, and good evening. Welcome to our webinar, Bidirectional Text, Part 1, The Basics of Bidi. My name is Ilungo Charan, and I'll be making introductions for today's event and going over some of the housekeeping items. As a reminder, this session is being recorded and will be posted to the Unicode Consortium YouTube channel. The next hour will be handled by our Bidi experts, starting with a video presentation, providing background information, followed by a Q&A period to address as many of the questions submitted as possible. Then let me introduce you to our webinar team. Richard Ishida sits on the Unicode editorial committee and the Unicode script encoding working group. Rusbe Pornader is vice chair of the Unicode script encoding working group. Karen Dawson is the community engagement and events manager at Unicode. And I'm Ilungo Charan, the vice chair of the community engagement team at Unicode. All right, let's get started.
Hello, and welcome to this talk about bidirectional text, Part 1, the basics of Bidi. The objectives for this session are to start from no prior knowledge and provide you with a basic awareness which we refer to as Bidi text. Using examples for plain text and for HTML. So let's get started. Most people are aware that right-to-left scripts include Arabic and Hebrew, but in fact there are a number of other scripts around the world where text flows from right to left across the page. Here are some examples of right-to-left scripts currently used around the world. The first set are scripts that are in fairly active use, and they include Adlam, and Arabic, Hanifi Rohingya, Hebrew, Unko, Syriac, and Tana, which is used in the Maldives. Unko and Adlam are African scripts. Then there's a set of other scripts that are also in use, still modern, but less widely used. And those include Mandaic, Mendeki Kakui, Old Hungarian, Samaritan, and Yazidi. There are quite a few archaic scripts, which are not mentioned here, that also flow from right to left. And sometimes either flow from right to left or left to right, depending on the author's preference. For consistency, the examples used in this presentation will all be from Arabic, but most of the concepts apply to all of the scripts that we've listed here. So, these scripts are referred to as bidirectional, or as I mentioned, Bidi scripts, because embedded text in other languages and digits typically flow left to right within the overall right to left flow of the text. So let's get started by looking at how to manage bidirectional text with this example. The first thing to note is that the text is stored and typed in logical order. That means it's what we call it. It's not. I'm not just saying it's logical to do it this way. I'm saying that is the kind of order that the name of the order. And it's contrasted with visual order. In other words, characters are stored and typed in the order in which they are pronounced. So here we have COVID and we have alikah, which means a vaccine. And if we list those characters, you'll see that the C and the O and the V and the ID are in the direction they're pronounced. No great surprise there. But the Arabic text as well, alikah, is in the order in which it is spoken, even though the presented word runs from right to left. So that's logical order. So how does the application know how to apply the appropriate order for these two words? It's because each character has a Unicode property associated with it to indicate its directional type. Latin characters have a directional type of strong left to right, while Arabic characters have a strong right to left direction. The application then uses these directional properties to determine which way the text should be displayed when a sequence of same direction characters are typed together. So let's see what happens when we type this in. COVID, the new letter gets placed on the right-hand side of the word. No great surprise, put in the space. And now we type in the Arabic, and then the and another and then the and you could see there that the text was progressing from right to left. And the new characters were being put on the left-hand side of the word. So this is built into the way that the algorithm, the bidirectional algorithm defined by Unicode, works. There's no need for markup. There's no need for special characters to make this happen. It's just automatic. Now, when you type a set of characters with embedded opposite direction text, such as the word COVID here in this right to left phrase, you end up with clumps of characters with the same direction. And these clumps are referred to as directional runs. So in this case, there are 3 directional runs. That's one going this way. That's another one going this way. And that's the third one going that way, of course. What's particularly important here is that the order in which these directional runs appear across the page depends on the surrounding directional context, what we call the base direction. The base direction for this example is right to left. And so the directional runs progress from right to left across the page. But if we switch the base direction to left to right, you see that the directional runs are now ordered from left to right across the page. In fact, if you add more than one piece of embedded text within a sentence, things can quickly become very confusing if the text is displayed without the correct base direction being set. Here's an example, which means in XHTML 1.0, so in XHTML 1.0, this is achieved by adding the inline element BDO. So watch what happens if we got the base direction wrong and said it dumped this text into a left to right base direction. And of course, your Arabic reader is going to start reading here and he's going to find it very confusing. So the important point is that the overall direction for a piece of text, the base direction, must be set correctly for the BiDi text to be readable. Let's take a moment to look at how to set the directional context of an HTML page to left to right. Let me just refresh this. So in order to make a right to left page, what you need to do is start with a dir attribute, meaning direction, of course, in the HTML tag. It's that simple. You give it a direction of right to left, and then all the text in the document will have a base direction of right to left, unless, of course, you override that for a part of the document. To override it for a part of the document, you simply use that dir attribute on the relevant block or the inline element tag to change the direction. So that would be to left to right in this case. Note that this should not be used on the body element. use it on the HTML element right at the top of the file, because the head element that precedes it may contain directionally sensitive text. Nor should the dir attribute be repeated on every paragraph or block in the page, which we often see. Just once at the top is sufficient. And again, you use the dir attribute only to change the direction of a portion of the page. Next example. Let's look at an example where we still have 3 directional runs, but each directional run now contains more than 1 word. So this is our first directional run. This is the base direction here is left to right. Here is the second directional run, and then the third directional run over here. Note that the space doesn't affect the directional run. That's because the space is a neutral character. Neutral characters is what we're talking about here. So it's not strongly direction. It doesn't have a strong directional property. It has a neutral directional property. In fact, most punctuation marks are also neutral characters and don't interrupt the directional run. So for example, I could add in here, I could add an exclamation mark, I could add a comma, I could add all sorts of punctuation, and it doesn't interrupt that directional run. In actual fact, if you like to think of it this way, the punctuation is taking on the direction of the surrounding text. This is important. They still create the directional run because of an important rule, and this is the rule. A neutral character between 2 strongly typed characters that have the same directional type. So here it's between that strongly right to left character and this strongly right to left character will inherit the same directionality. And so it continues the directional run. However, let's try something different. Start out with the same phrase. Suppose the title in Arabic actually ends with an exclamation mark, which is part of the Arabic phrase that we're quoting. So I'm going to put the exclamation mark in here at the end of the Arabic phrase. And well, that's in the wrong place. It should appear to the left of the Arabic text, so over here. And this is because this is expected, because it follows another important rule, which is when a space or punctuation falls between 2 strongly typed characters that have different directionality, so in this case, right to left and left to right, the neutral character or characters inherits the same directionality as the surrounding directional context. So the surrounding directional context for this phrase is left to right, and therefore the exclamation mark gets posted as if it was part of that left to right text. So how do we fix this? Well, it can be fixed using a Unicode code point that is an invisible formatting character, and we call it RLM, right to left mark. And it's a character which, although you can't see it, has a strong right to left directional property. So let's add that in. We're going to just select to the other side of the exclamation mark, and I'm going to type in an RLM. And hey presto, we get what we wanted. The exclamation mark is now over on the left-hand side. Just to show you what went on there, here's this application converts the invisible characters into visible text, it's left to right text, of course, so the example doesn't work while that is showing. But if I remove that, convert it back into the RLM character, then you see that we get what we want. An alternative, there is an alternative, which is to use a pair of characters. So let's take that out again. And now we have the exclamation mark in the wrong place. And what I'm now going to do is I'm going to select the whole of the Arabic phrase, and I'm going to insert two characters. And let's see what they are. So the first character in the text stream is called RLI, right to left. Isolate is the name. And that says, from this point onwards, make the base direction right to left. And then the PDI, the pop directional isolate character, says, okay, that's the end of that range. And then we go back to what we had before. So again, this doesn't look right at the moment because they're not the actual characters, but if I convert them back to the actual characters, you see we get what we want. And just to prove the point, if we list these characters, you can see that we have the S, and then we have the RLI character. Then we have the Arabic text in the order in which it is pronounced, and then the exclamation mark, and then the PDI formatting character, and we space and the I for in. One thing we should note here is that we could have used an older set of formatting characters here, and they are called RLE, right to left embedding, or LRE, left to right embedding, and PDF pop directional formatting. These have now been superseded by RLI and LRI and PDI because they don't isolate the range from the surrounding text. More about that later. In HTML, we can achieve the same result using the dir attribute on a span. So here we have an example. We would put the title is, and then we'd have this opening tag with a dir attribute and right to left value. And then we'd have the Arabic phrase inside there, and close the span. And that would achieve exactly the same result in HTML. This indicates that a right to left base direction should be applied to the tag between, to the text between the tags. Another important point to make, though, at this this point is to ensure that you don't use these formatting codes in HTML that I've been describing, these ones here, except for limited circumstances, and those are in attributes where you can't use markup, and in a few elements which accept only plain text. But the rest of the time you should use markup to manage the text wherever possible. The Unicode formatting characters are used for plain text where you don't have markup available. Also, don't use CSS to manage BiDi. Use markup. CSS is presentational sugar that may not always be available, but directional information can affect the semantics. So it needs to always remain with the semantic content, i.e. the markup. So that's why you should always use markup rather than CSS direction properties and so on and so forth when writing HTML. Now, embedded direction changes. This example is slightly different because it doesn't just involve punctuation. The W3C is part of the name of the organization in Arabic and should appear to the left of the Arabic text, so over here, which means the internationalization activity, comma, W3C. And of course, that doesn't look right as is because the the whole of the direction here is set to left or right. Now, unfortunately, this can't be fixed by the RLM. Let's try. Click at the end here, and I'll put in an RLM character. Nothing changed. We'll check that it's actually there. Yes, it's actually there. So it didn't resolve the problem. And that's because these are strongly directional characters, so that's expected. A solution here requires the use of the RLI pairing. So if we highlight that phrase, and then we add RLI and PDI, then we get what we would be expecting. The organization is English, but then the name of the organization, Nashat Atla Dwil W3C, progresses from right to left. To achieve this in HTML, we do basically the same as before, but there is a small wrinkle. So here we go. We'd have organization, colon, and then we'd put span, direction is right to left, and we put the whole phrase in there. However, you'll note that we wrapped both changes in direction in markup. So the W3C is also wrapped in markup that says that the direction is now left to right. This doesn't cause any problems, but it makes it easier for content authors to know what to do. The rule is simply tightly wrap each directional change. So that means you wrap the overall phrase and then you wrap a change within that phrase. This approach means there's no need to figure out whether to use an RLM or the paired formatting characters or various other difficulties that can arise. You just put markup around everywhere that the text changes direction. Now, a couple more things. Numbers normally run left to right within the right to left flow. So here, this would be the number 1234, and that runs left to right. However, what's important here is that because these are weakly typed characters, they don't break the directional run. So there's only two directional runs here. There's this one here going left to right, and then there's this one here that goes right to left. Yeah, well, okay, let's do it this way. That's all one directional run. It doesn't break into three. And actually that happens also if you're using these squiggly characters that you might find in these other scripts. They behave in exactly the same way. However, I should mention that digits in ADLAM and UNCO scripts are somewhat different. In ADLAM and UNCO, the African scripts, the numbers or the digits are strongly typed right to left characters, which are read from right to left. So this number would, if this was an ADLAM phrase, would actually say 4,321. And the same goes if you use the ADLAM digits. But they still don't break the directional run, and that's important. Okay, so numbers prolong the directional run of the characters that come before. Next, mirrored characters. This is another important feature related to BiDi. In this example, the angle bracket is exactly the same character throughout. So if we select this and we list the characters, you can see it's greater than sign in the English text, and in the Arabic text it's still a greater than sign, even though it points in the opposite direction. And that's because the glyph used to display the character is chosen according to the prevailing text direction. So most of these mirrored characters are paired characters, such as parentheses or brackets, but there are also some standalones which get flipped according to the direction of the text. It's important to note, however, that quotation marks are not mirrored. Let me give you an example. Let's take these out, highlight this, add a couple of quotation marks. And if we look at the characters there, we see that it starts with a right double quotation mark and finishes with a left double quotation mark. So in the case of quotation marks, right in the character names means place it on the right, and left means place it on the left. If you translated this text into English and didn't change the quotation marks would look very strange. They'd look the wrong way around. Isolation. We briefly mentioned this before. Let's look at why it is important. It is an important topic. In many cases, it's important to isolate a change in direction from the surrounding text. Otherwise, spillover effects creep in and corrupt the display. In this example, we have a list of country names in Arabic, and it is out of order, and the comma is kind of in a weird place there. So Egypt, Misr, should be over on the left-hand side, and that's the first item in the list in this piece of actually English text overall. Now this occurs because the application assumes that the comma is the same directional run as the words on either side. So you have a single directional run going on here. In fact, the comma is part of the English text and therefore should break the directional run, causing a reordering of the items in the list. To achieve the correct ordering, what do? Well, we wrap each Arabic word in the RLI PDI formatting code. So we select that one and we put that in. Well, that's actually solved the problem straight away. And you can see that that looks like an English list now. So we've already solved the problem. If you want to follow the rule that we mentioned earlier, we would put this these directional formatting characters around all of the changes in direction. That makes things a little more consistent. It would maybe help when we're editing the text in the future or sticking something into that phrase and so forth. But it doesn't do any harm. So now the characters we inserted isolate the internal text from the surrounding text, and the comma is correctly interpreted as part of the English content. The next example is also about isolation. And this example is also about inserting strings into text. The curly brackets show items that will be dropped into an English language list and the order in which they should appear. This one, then the word reviews. The overall direction here is left to right. And the list may contain book titles from various different languages. And in this particular example, this line happens to be have an Arabic book title in it, which means the design and creation of websites. However, there's a problem here because you see the 4 is over on the left-hand side and it should be just before reviews. So in this case, the number following the Arabic text needs to not be regarded as a continuation of the directional run that starts with the Arabic characters. We saw that when we were talking about numbers before, that continues one directional run. So how do we solve this problem? Well, you might be thinking, okay, select the Arabic text, which is the title, and use RLI and PDI to make it look right. Well, that would actually work. There you go, it works. But only if you knew that the direction was supposed to be right to left. And actually, when you are dropping titles into this list, you don't really, because it's a multilingual list, you don't know whether the direction should be right to left or left to right. So let's take that out and start again. What can we use? Well, there's a formatting character called FSI, or first strong isolate. And if we use that instead of RLI, like this, we get the same result. So here we are, FSI, and then PDI, and everything within that is treated as a particular direction. And the way that the direction is determined is by looking at the first strongly directional character in the phrase and using that to determine the base direction to be applied to the phrase as a whole. So in this case, the first character is the, and that's right to left. And so we're applying a right to left direction here. So that's first strong heuristics that we're dealing with here. Put that back. Now, so how do you do this in HTML? In HTML, the dir attribute automatically applies isolation to a span. But there's also a special element called BDI, which can be used if you don't know the direction of the string to be inserted, which is the case here. It works out the direction using first strong heuristics at the same time as isolating the text. So here is what you would type in. You've got BDI, then you've got the title, and then you've got close BDI. And this is the same as the characters that we were using up here. And that'll produce the same result. Alternatively, you could also use the following. Span rather than BDI, and then you use an auto attribute on the dir, an auto value on the dir attribute. And that auto attribute does the same thing as the FSI code. It looks to see what is the first strong character, and it sets the base direction for everything within the span to that direction. Okay, what's next? The fact that you can't necessarily know the direction needed for a string that is inserted into content can cause significant problems. In this example, you can't actually tell that this is wrong. This is supposed to be a MAC address that has been inserted into a right to left list item. But if you try to use what you see, you won't be able to contact your device. And that's because this is being ordered incorrectly. So let's put in our FSI and PDI characters. Oh, did I do that? I didn't get it right. Get there in a minute. Okay, highlight that. FSI, PDI, and there we go. All right, so that is the actual MAC address number, which you wouldn't have really been able to easily guess at. By the way, we should also briefly mention that expressions and ranges in right to left text work differently, not only from script to script, but sometimes from language to language within the same script. This is especially the case where there is no lead-in text. So if this was not there, for example, and we had a range here or an expression such as 1 + 1 = 2, the ins and outs of this are too complicated to explain here, but you can find information about it at the following link, which is here. Finally, we need to add a caveat about first strong heuristics. Unfortunately, there are circumstances where first strong detection doesn't work, and this is an example of that. This is the name of a publication And the publication is called, if you translate it into English, HTML and CSS, designing and creating websites. And so the Arabic name for that publication in the Arabic, the HTML and the CSS should be over on the right-hand side, and then you get the colon, and then you continue to the left with the Arabic text for the bit that says designing and creating websites. So, okay, it's assumed that perhaps we're dropping this into a list of publications. So let's apply our FSI and PDI, and nothing happens, right? It's there. Well, that's because the FSI is looking for the first strong character, and then it's applying the base direction on the basis of that. But the first strong character is an H, which is left to right. So it doesn't get it right. So what do you do? Well, unfortunately, there is not much that you can do unless you know that this is really a right to left string. Let's reset that. What we really needed to do was apply RLI PDI, and then we get what we would expect to see, HTML, CSS, and so on. There we go. The problem is that you need to know the direction to be able to choose the RLI rather than the LRI character. But how can you know that? Well, you can't, unless the strings are accompanied by metadata. The consumer of the string should recognize that metadata and then insert appropriate support for the text when it's inserted when the string is inserted into the content. So if you want to know more about that, go and read this document here, string meta. We don't have time to get into this in more detail, but there's a lot more detail at that location. So in fact, we're probably about the end of our time here. Before we finish, I want to look back over what we've talked about. It's quite a lot of stuff, even though we're still doing basic things here. Characters should be stored in logical, not visual direction. Directional properties of characters clumped together into directional runs. The surrounding base direction determines the order of directional runs across the page. A neutral character between same direction characters takes on the same direction. A neutral character between different direction characters has the direction of the higher context. RLM and LRM can sometimes solve a problem, but it's generally easier to tightly wrap all changes in direction using paired formatting characters. Numbers don't break directional runs. Some characters are mirrored automatically, but not quote marks. Isolate directional runs. Use RLI, LRI, not RLE and LRE. And use FSI when inserting text into a page. But remember that some cases are likely to require sidecar metadata for correct handling. For HTML, it's really fairly simple. Use markup, use the dir attribute, set it to right to left or left to right wherever possible, and only use the formatting characters we talked about in plain text only situations. Don't use CSS. And use BDI when inserting text into a page, because BDI will try to figure out the direction of the text. And hopefully that helps advance your understanding of how to work with BiDi text, both in Unicode plain text and in HTML. And for more information, please follow these links. The link at the bottom takes you to a set of pickers. You've got Arabic and Hebrew and all sorts there, which you can use to experiment with these ideas. This application I'm using for the presentation is a modified version of those pickers. So hopefully that's helpful. Thank you very much. And good luck with your Bidi work.
Thank you so much, Richard, for that presentation. Now I'd like to ask Ruzbe and Richard to address some of the questions that we have. In this Q&A, we received many questions in advance. So we'll address these during this webinar, and we'll be taking additional questions as time permits. But remember to ask questions that are on the topic of this event. So because our time is limited, I apologize if we can't get to all of the questions. Okay, the first question that we have is submitted by Rahaf Farag. Bidirectional transcripts cannot be used as a basis for conversation analysis. Is there a way to merge scripts or render temporality?
Yeah, my understanding is basically the text that they're receiving somehow from the transcript is in visual order. And basically what Richard also explained in the presentation is basically Bidi text and any text in Unicode is best represented in what we call logical order. So logical order, reminder, what is it? Logical order is the order you pronounce things. So a clean text would basically be would have been stored in a right to left direction for right to left text and in a left to right direction for left to right text. That's what you should expect your input from any good tool to be. In this specific case, it looks like they're receiving their text in a visual order, which is basically potentially reverse order for Arabic text. In such scenarios, basically there are tools in ICU, for example, in our internationalization library, that convert visual order to logical order. Basically the reverse of the Unicode Bidi algorithm that you can theoretically use for such scenarios. It's not going to be a perfect tool, but it may be able to help in such a scenario. But generally, what you should expect is for your text to be in basically pronunciation direction. Richard, do you want to add anything?
I think that's fine. Thanks.
Okay.
All right, thank you. The next question. Bidirectional text with special characters like full stop or even spaces could cause mirroring issues. So how do we handle this in G-Sheets? And this was submitted by Arwa Alea.
G-Sheet is Google Spreadsheets, is that?
Yeah, that's correct.
Okay, yeah, so I can try to give some general guidelines about this in various tools, and then I actually don't remember exactly how Google Sheets works right now, but from what I remember, I can tell you. Basically, a lot of these tools have buttons or UI controls that you can set the direction of a cell in, for example, or the direction of some text if you want to do a word processing software, for example, you may be able to select some paragraph and set that paragraph direction. In these examples, in a spreadsheet, you want to set the direction of a specific cell, for example. What you can try to do is, again, it really depends on the software. And I think, for example, for Google Spreadsheets, even the mobile version is different from the desktop version. The mobile version has more limited features, for example. In the desktop versions, with some of these Google tools, you need to go find the document settings, and they're basically enabled Bidi. Sometimes the Bidi controls are not enabled by default. You go enable those there, and then you get extra buttons that then you can set the direction of a cell in, for example. In Microsoft Excel, for example, there are similar functions, stuff like that. But basically, that's the idea of the direction of the whole text that you can set. And those are the things that determine the direction of the neutral characters like spaces or punctuation. If your tool doesn't allow those things, maybe you can also hack your way using bidirectional controls. As Richard was just saying, for example, you can put your text in FSI and PDI pairs, or RLI and PDI pairs. Basically, with those, you can control the direction of the cell. Once again, Richard, if you have anything to add.
Yeah, no worries. I'll jump in if I want to add something.
Perfect. Okay.
Okay. The next question: are there any tips or tools for bidirectional text to adjust any flipping? And this was submitted by Yasmin Saad.
Yeah, I'm sorry. Could you repeat? I'm not sure I understand the question.
Yeah, this is just how I interpret what's written. So any BiDi tips or tools to adjust flipping, and maybe flipping is about
So
texture.
if you mean graphical tools, I mean, there are sometimes you can do some flipping using, if you have icons, you need to flip from right to left. There are some tools you can do that. CSS has some tools. I remember there was a tool called CSS Janus, G-A-N-U-S, that basically would flip various elements of a web page for you in CSS. But I'm not sure I understand the question really. Again, if Richard has anything, maybe he understands better.
Yeah, I think that reference to CSS Janus is a good point. I think that might answer the question.
Yeah.
I mean, there are certain things, as I mentioned in the presentation, that will automatically flip, but there are other icons and stuff like that that you might have to take care of if you're doing localization.
Yeah, it's something I would say. There's also various guidelines by basically various software vendors, including Google. I'm going to paste one of them in the chat right now that tells basically what should be flipped and what should not be flipped in a right-to-left environment. They're not perfect, but they're a very good start for somebody who wants to figure out how to flip a user interface, for example.
Right, and just to add some extra context, we've been talking about text in this presentation, but you're also talking about the graphical elements that are not text, like icons, and a lot of icons have directionality, but some of them don't have directionality, and so then the guidelines help clarify.
Yeah. So for example, if you have an idea of some, generally when you have right to left. When the user chooses the right to left language, they expect certain elements to also change to right to left. So for example, a back button, which typically is an arrow pointing left in a right to left environment, would be an arrow pointing right. While, for example, the play button, which plays some media, usually doesn't flip in a right to left environment. So basically, this is basically a bunch of knowledge that you need to kind of know from what is the custom for BiDi user interfaces. And a lot of those are explained in the link, for example, that I just provided.
Okay. I thought the play button actually has directionality, but something like a cup or a magnifying glass doesn't.
Yeah, the play button also, yeah.
Just by convention doesn't change.
Oh, I see.
Yeah.
Okay.
Yeah, it's direction of tape, as they would say. Tape still goes in the same direction. That's basically, why don't you flip the play button is because if you go to the Middle East, the tape recorders also had the same direction. They didn't flip it.
Oh,
so
okay.
we draw from the real life.
Okay.
Yeah.
Thank you. Next question. How can I design HTML or CSS for BiDi content or localization by me?
So if you want to design a single HTML page that then you can basically put either left to right or right to left text, basically it would depend on, you need some kind of templating language. So it would depend on that templating language. But generally, as Richard was saying, for example, if you have a right to left HTML page, you want to put a right to left at the very top element and set directions there, right? You can either use a templating language to switch these things around, Or you can also try some tricks with CSS. As I mentioned, the CSS JNSO may be able to provide you with left to right or right to left CSS alternatives. There's also, if I remember correctly, there are also various kind of more advanced ways of doing this in CSS, but I don't remember them from the top of my head. Richard, do you want to jump in here?
Yes, I'll jump in. So one of the things that I mentioned was that if you tightly wrap all changes in direction, that makes life a lot simpler for the people who are writing the content and for handling it later on. So that's one of the things that you could consider doing to make localization easier. But there's also a set of new property values available in CSS. I say new, I mean, they're not that new, but they are called logical properties. And I didn't have time to talk about that in the presentation, but I'll put a link in the chat. If you follow that link, you'll get a bit more information. We're currently at the W3C in the process of writing a full article about this stuff. That's just a small summary for the time being. The article will tell you how this works for vertical text as well as for right to left text. But I strongly encourage you to use these logical values, which would be things like start and end rather than left and right, and so on and so forth. And that does real help for localization.
Yeah, just to explain a little bit here more, the idea is, for example, instead of saying align this thing to the right or to the left, that then you would need to change from right to left or left to right, you would say align this thing to the start. And that start, depending on the actual content of the HTML at that moment being right to left or left to right, would switch direction to the place that you want.
Hey, Lango, we've had some people with their hand up for quite a long time. I wonder if we should. Can we take that question? Or?
It would be better if we can go through. Let's see. We have some in the Q&A, so I'd like to take those that are written in the Q&A. So the first one from the Q&A is from Chengwei Wu. In the example of organization ... W3C, it seems to me without knowing the markers, the reader may read it wrong. Is that possible?
Well, okay. So first of all, if it's being read out loud by a text-to-speech thing, remember that everything is logically encoded and therefore it'll come out in the right order. If you're reading it off a screen or off printed paper, then the idea would be that the content author should have intervened beforehand to put in the formatting characters or the markup that's necessary to make it to get it to be rendered in the direction that you would expect. But I don't know if that answers the question, but I think that's the answer.
Okay. There's another Q&A question, and it's asking about translation management systems like SmartLing, Phrase, and Crowdin. Do either of you know much about that? Because they're asking how we handle these concerns in those types of translation systems.
Yeah, I don't know much about that, I'm afraid.
Okay.
I've used some of these things when I was working as a localization engineer, but they change a lot. And my general advice is, if you're a developer that is basically on the receiving side of these things, try to make the life of the translator who's doing these things as easy as possible and isolate them from these issues as much as possible. If you're working in HTML environments, as what Richard was mostly talking about, in HTML environment, try to use the right markup, right CSS as much as possible. So the translators would not need to put the marks unless it's an exceptional case that they need to work around and things like that. Also in environments such as Android, for example, there's something called the Bidi formatter that takes care of a lot of these issues for you. instead of requiring the translator to put some of these things for you. The example that comes to my mind is, for example, when you have a template that there's something to insert in the middle, the thing that gets inserted in the middle could have different direction, and you can either ask the translator or the linguist to put the right markup so it works properly, or when you're actually inserting the text yourself in your code, you can put the markup there. So always, I always recommend that you try to put the markup yourself in code there, as opposed to asking every linguist for every right to left language to put them there.
All right, thank you. Oh, this pains me to say it, but I think we that should be our last question, and we need to wrap up. But that could also be a good segue for what we have next. So let me share our closing slides here. So here are some bidirectional text resource links that we hope you will find useful. I'd like to acknowledge and thank the organizational members of Unicode that support the work that happens at Unicode, which includes emoji standardization, as you heard today. Oh, and so here are our organizational members. And save the date. Please remember that there is a second part to the bidirectional text virtual event that will take place on August 13th, 2024 at 10 a.m. Pacific time. Registration information will be coming soon. And there are so many questions that we couldn't get to today. And I hope that if you still have questions that you'll be able to, find some answers at that event. And now I'd like to thank Richard and Ruspe for sharing your insights with the answers in the Q&A. Thanks to our logistics team today for the work that you've done leading up to today and as well as making today possible. And finally, thank you to all of you in attendance for making this event a success. We'll plan to have the recordings for this event available in the coming weeks, and a survey will go out within the next 24 hours. So we hope to get any feedback that you'd like to share. For any general questions regarding Unicode, please visit home.unicode.org. And we hope you stay connected with us for any further information, future events, and please feel free to share any information that we've shared with you today with other folks. So thank you all and have a great rest of your day or evening. All right, goodbye.